All right, moving on to question number 4. All right, so the half-life of phosphorus-32 is 14.26 days. Calculate its decay constant. So when we're talking about half-life, we're talking about basically the, the the decay of a certain material. So I spelled half-life wrong. Okay, so basically the half-life is a measure of time, which helps us understand how fast or how slow a substance decays, and it's measured by um, measuring how fast it takes a substance to decay to 50% of its capacity, right? So, for example, if we had substance A, for example, right, and we weighed it out and we know it's 100%, right? So the half life is the measure of time it takes to have this substance decay to 50% of itself. So this is what a half-life is, okay? And the notation for it is T with the half in the subscript here, and that helps us to denote that as a half-life. So usually this is applied to radioactive materials and unstable isotopes, for example, because they take a certain amount of time to decay. And by measuring out its half-life, we can have very useful applications such as carbon dating, or by understanding how effective a pharmaceutical is. So a half-life is very important for that kind of stuff. So let me just write out that definition here. So the half-life can be calculated by dividing ln of 2 divided by what we call the decay constant. So this decay constant is what basically determines how fast or how slow a half-life is. Okay. So in this case, we know that phosphorus-32, the half-life of it is 14.26 days, right? So what we're given here is T of half equals 14.26 days. All right. So if we want to calculate the decay constant, we need to plug it into our equation here. So 14.26, I'm not going to include the units here, equals ln 2 divided by k. So we have k equals ln 2 divided by 14.26. Okay, that makes sense. So the decay constant is going to be 0.0486, and it's going to, the unit of the decay constant is going to be whatever it takes to cancel out this. So since ln of 2 doesn't have any units, and this has a unit of days, when we're isolating for k, we have to be worried to get rid of these units here. So k is going to be days inversed. So yeah. So per day, so this basically means the decay constant means that the substance per day decays 0.0486 of itself. Or if I were to times that by 100, it would be like 4.9% of itself. It loses 4.9% of itself per day. So that's what the decay constant tells us here. Okay. So why I included this question in the in my session today? This is more of a chemistry question. It has something to do with the function itself, right? Because we know the logarithmic function is basically is the inverse of our exponential function, and it has. So I just wanted to connect the relation between mathematics and chemistry here, and I thought it was also a cool question because it was included in the mathematics section for some reason. So anyway, so that's how you calculate the K constant. And the half-life of any material is the time it takes for a substance at 100% capacity to decay to 50% of itself. And one more thing to note before I even end is that if we extrapolate from this diagram more, so if say we have substance A, and we go through two half-lives, so the second half-life is going to be 1/4 of A. The way half-life works is that it's the time it takes for the current state of the substance to decay to halfway. So if you can extrapolate from here, a quarter of a substance, if you go through a third half-life, is 1/8 of itself. And that's a function of the exponential function itself, right? The smaller the substance, the less it decreases. But that's the last thing I want to note about that. There's a trick, or there might be a trick where like you think, oh, after the second half-life, it's going to decay to 0, but it's always half of its current state. Okay, so in theory, this will never decrease to 0. It will decrease to very minimal amounts, but it will keep going. It'll just keep going. Anyway, that's my spiel on that. So this solution is correct. Let me just check the math real quick here, just to make sure that nothing is sketch. So 0.3, so 1 of 2. Okay, that equals that, divided by 14.86, or 26. Yeah, so he rounded to 4 decimal places, which is correct. Okay, so that's correct. All right, moving along to question number 5. All right, so back to regular math. Let me just say this solution is correct. Good work.